Valve actuators control fluid in a pipe by varying the orifice size through which the fluid flows. Control valves contain two major components, the valve body and the valve actuator. The valve body provides the fluid connections and a movable restrictor comprised of a valve stem and plug that is in contact with the fluid that varies the flow. The valve actuator is the component that physically moves the restrictor to vary the fluid flow. Three actuator types are used in control valves, and they include spring and diaphragm, solenoid, and motor. As the name suggests, the spring and diaphragm actuator uses a spring and a diaphragm to move the valve stem and plug. A 15 psi pneumatic signal enters the housing at the top of the actuator. As pressure is exerted on the diaphragm, a downward force is applied against the spring, which moves the restrictor. The diaphragm moves until it creates an equal but opposing force against the spring, at which time the motion stops as the plug meets the valve seat. With no air pressure, the restrictor is pushed upward by the spring to act as a normally open control valve. To vary the position of the restrictor and flow through the valve, a current-to-pressure transducer can be used to provide a 3 to 15 psi signal to the diaphragm. At 3 psi, the valve is maintained open, and at 15 psi, the valve is maintained closed. Pressures between the 3 to 15 psi range proportionally change the flow of the valve. For example, a pressure of 9 psi applied to the diaphragm moves the spring and valve stem to 50% of operating range. For on-off control of the valve, a solenoid is used to actuate the valve to a fully closed or fully open position. Applying current to the coil generates a magnetic field that moves the plunger downward against the return spring. With zero current applied to the coil, the spring pulls the plunger upwards to the fully open position for a normally open state control valve. Another method for variable valve positioning uses a motor and is referred to as proportional control mode. Using a gear motor attached to the valve stem, a servo amplifier provides a DC control signal that moves the valve to the desired position. Feedback is achieved with a wiper arm attached to the valve stem that sends a signal back to the servo amplifier where the position is monitored. The servo amplifier drives the motor until the control signal is equal to the feedback signal.